Hi, Assalamualaikum. My name is NUR AMIRRA SYAHILA binti AHMAD BUSTAMAM. So today I will present about my assignment 2 in subject ENT323 electrical machine and drive. The question that given to me is explain the working principle of a dialysis machine. Propose suitable electrical motor and drive that can be used for hemodialysis. First, we need to know what is the dialysis. Dialysis is a treatment that takes over kidney functions if those organs stop doing their job with the help of a dialysis machine. There are two types of the dialysis machine. First is hemodialysis. In this type, blood is put through a filter outside the body called dialyzer. It will clean the blood and return back to the body. In the hemodialysis, it removes the waste and water by circulating the blood outside the body through the external filter, which is dialyzer, that contains a semi-permeable membrane. Second is peritoneal dialysis. In this type, a special fluid, which is dialysate, is being put into abdomen and the blood is being cleaned inside the body itself. We know that in a peritoneal dialysis, a soft plastic tube, we call it as a catheter, is placed inside the body of the patients by surgery. Sterile cleansing fluid is put into the belly through the catheter. After the filtering process was finished, the fluid leaves the body through the catheter. Working principle of dialysis machine. The principle of dialysis works on the diffusion of a solid across a semi-permeable membrane. It also involves passive diffusions, ultrafiltration, convection, and also osmosis. It works when blood flows on one side of the semi-permeable membrane, whereas the dialysis fluid flows on the opposite side. There is a special substance known as the dialysate is used to pull the waste out from the blood. For passive diffusions, a high to low concentration gradient is present between the patient's blood and dialysis solutions, which is dialysate used. For ultrafiltrations, excess fluid is cleared from the body through the pressure gradient, moving fluid from a high to low pressure regions. For convections, allow the effective clearance of larger molecules from the blood by creating a higher hydrostatic pressure, leading to passive movement of solute in fluids. So in this part, we focus on the hemodialysis machines. So in hemodialysis, the patient's blood is pumped into the dialyzer through the blood compartment of a dialyzer, exposing it into partially permeable membrane. The dialyzer is composed of a tiny hollow synthetic fiber. The fiber wall acts as a semi-permeable membranes. So the blood flows the fiber. Dialysis solutions. Electrical motor and drive that can be used in hemodialysis. First is stepper motor. Several valves with electronic actuations are needed in the machines to allow variable mixing ratio. Simple open or close valve driven by solenoid to precision variable position valve driven by the stepper motor. Stepper motor also can use in the peristaltic pump. This pump require a significant amount of power and are driven by either AC or DC motor with variable speed control. For the lower volume fluid such as heparin, a shrink pump mechanism is commonly used driven by a small stepper motor. Precise measurements of proper mechanism advance is needed in the hemodialysis mechanism. Next, the electrical motor and drive that can be used in hemodialysis is brushless DC motor. In hemodialysis system, require reliable peristaltic pumps to accurately pass the patient's blood and the dialysis solution through the machine's dialyzer. Precision brushless motor provide reliable, quiet operation for these life-giving machines. The principle of the BLDC motor is to energize the pace fair, which can produce the highest torque. In this application, the combination of the DC current with a trapezoidal BMF, which is the back EMF for brushless DC motor, makes it theoretically possible to produce a constant torque. Next is control bridge rectifier. Due to long durations of the dialysis process, all dialysis equipment is AC line power. Standard AC-DC converter meeting medical safety standard are employed. The rectifier circuit is used to convert the AC into the DC. Control solid-state device like MOSFET and IGBT are used to vary the output power at different voltage. By triggering this device at various instants, the output power at the load is appropriately changed. The control bridge rectifier used to ensure low conduction losses and design choice is high system efficiency. Lastly is MOSFET. Due to variety of components require power, a variety of voltage rail are needed at different power level. A power system with multiple output switching regulator is needed with a significant amount of linear regulation at the load for non-sensitive precision. Lastly is MOSFET. Due to variety of components require power, a variety of voltage rail are needed at different power level. A power system with multiple output switching regulator is needed with significant amount of linear regulation at the load for noise-sensitive precision circuit. That's all from me. Thank you.